If you were thrown into the bottom of the Mariana Trench without any protection right now, you would experience a terrifying force 1,100 times greater than the pressure at the top of Mount Everest in just 4 seconds. Your bones would shatter like biscuits, and your body would be instantly compressed to the size of a basketball. But this dark abyss that devours everything actually hides life codes more mysterious than the universe. Can humans really reach the deepest part of the ocean? What cognition-shattering secrets lie there? We live on a planet wrapped by oceans. 71% of the Earth's surface is covered by seawater, and the average depth of these blue territories reaches 3,700 meters, equivalent to the height of 12 Eiffel Towers stacked together. Yet the marine areas familiar to humans account for only 5% of the total volume. The remaining 95% of the deep sea is more unfamiliar to us than the surface of Mars. But this darkness is not unrelated to us. Temperature changes in the deep sea affect global climate. Seabed mineral resources support modern industry. And even the survival methods of deep-sea organisms are rewriting our understanding of the limits of life. Today, let's dive into the sea together, from shallow waters to the 10,000-meter abyss, and gradually lift the veil of mystery over the deep sea to see how far humans can reach in the ocean. The vertical world of the ocean is like a giant skyscraper, with each layer having a distinctly different environment. The first layer is the euphotic zone, ranging from the sea surface to 200 meters deep. Here, sunlight is abundant, making it a paradise for marine organisms like fish and corals. The maximum depth for recreational diving, which we are familiar with, is usually around 40 meters, equivalent to 4 atmospheres of underwater pressure. Further down to 1,000 meters is the dysphotic zone, where sunlight is too weak for photosynthesis and the water temperature drops to around 4 degrees Celsius. Organisms here have evolved bioluminescent organs, such as the glowing lure on the anglerfish's head. Below 1,000 meters lies the true deep sea, known as the aphotic zone. It is perpetually sunless, with water temperatures remaining between 0 and 2 degrees Celsius year-round, while pressure increases sharply with depth. For every 10 meters descended, pressure rises by 1 atmosphere, equivalent to a 10-kilogram object standing on every square centimeter of area. At a depth of 2,000 meters, the pressure reaches 200 atmospheres, enough to crush ordinary steel containers. And this is just the beginning of the deep sea. What is the limit of human free diving without equipment assistance? In 2014, a free diver set a record of 170 meters, but he could only stay underwater for a few minutes and had to endure enormous physiological pressure. Beyond 100 meters, seawater pressure compresses the lungs, causing a sharp drop in blood oxygen levels. Meanwhile, nitrogen dissolves in the blood, triggering nitrogen narcosis that induces hallucinations, similar to being drunk. For scuba diving with oxygen tanks, the maximum depth is only 330 meters. This is because the greater the depth, the higher the proportion of helium required in the oxygen tank. Otherwise, severe physiological reactions will occur. But even the most advanced diving equipment cannot allow humans to stay in the deep sea for long periods, as the pressure resistance requirements for equipment increase exponentially with every 1,000 meters of descent. This is why deep-sea exploration is more challenging than space exploration. Space is a vacuum environment, while the deep sea is an extreme environment of high pressure and darkness. Humans first attempted to reach the deep sea in 1930, when an American explorer descended to 137 meters in a bathysphere, marking the beginning of deep-sea exploration. In 1960, a Swiss engineer and a U.S. Navy officer piloted the bathyscaphe Trieste to a record depth of 10,916 meters, successfully reaching the bottom of the Mariana Trench. They stayed there for 20 minutes and observed a previously unseen flatfish, shattering the belief that no life exists in the 10,000-meter deep sea. However, the mission was fraught with danger. The submersible's observation window developed a crack under high pressure, nearly leading to mission failure. In the decades since, deep-sea exploration technology has advanced continuously. In 2012, director James Cameron piloted the Deep Sea Challenger solo to 10,898 meters, becoming the third human to reach the bottom of the Mariana Trench. He stayed there for 3 hours and captured precious deep-sea images. In 2020, China's Findus Striver submersible successfully descended to 10,909 meters and achieved long-term seabed operations, marking China as one of the few countries mastering 10,000-meter deep-sea exploration technology. These missions tell us that with the power of science and technology, humans can indeed reach the deepest part of the ocean, but each dive is like a gamble with death. The Mariana Trench is the deepest point in Earth's oceans, reaching a depth of 11,034 meters, equivalent to inverting Mount Everest, with its peak still over 2,000 meters below sea level. How extreme is the environment here? First, the pressure, 1,100 atmospheres, equivalent to an elephant standing on your fingernail. Ordinary steel would compress and deform under such pressure. Second, the temperature. It remains between 1 and 4 degrees Celsius year-round, bitterly cold. Moreover, it is perpetually dark with no sunlight. The only light source comes from the bioluminescence of deep-sea organisms. Additionally, the seawater in the deep sea is completely stationary, with no currents or oxygen exchange. The environment here is harsher than the surface of the moon, yet life has still found a way to survive. The 10,000-meter abyss is not a forbidden zone for life. Instead, it hides many bizarre creatures. For example, male anglerfish are only a few centimeters long, and their lifelong mission is to find a female and parasitize on her, becoming part of her body. There are also barrel-eye fish, with transparent heads and rotating eyes that can detect faint light above them. More surprisingly, the deep sea is home to giant oarfish up to 10 meters long, as well as deep-sea shrimp that can withstand extreme pressure. The survival methods of these organisms subvert our understanding of life. They do not need sunlight, relying instead on chemical energy from hydrothermal vents. Their cell structures are also different from shallow water organisms, with more flexible cell membranes and enzymes that remain active under high pressure and low temperatures. Scientists have found that deep-sea organisms generally have long lifespans. Some deep-sea shellfish can live for over 200 years because the low-temperature environment slows down their metabolism. These creatures are like inhabitants from another planet, showing us the infinite possibilities of life. Why do many people feel intense fear of the deep sea? This fear stems from human evolutionary instincts. The deep sea represents the unknown, darkness, high pressure, and isolation, all factors that threaten life. When faced with endless darkness with no reference points, we experience a strong sense of insignificance and helplessness. This feeling is similar to space anxiety, but the oppression of the deep sea is more intense, as seawater presses against your body from all directions. Furthermore, there are many unknown organisms in the deep sea, and humans instinctively remain vigilant towards unknown creatures. In addition, numerous accidents in deep-sea exploration, such as submersible disappearances and crew strandings, have deepened people's fear of the deep sea. But on the other hand, this fear also drives humans to explore continuously, because human curiosity always overcomes fear of the unknown. Why do we spend enormous costs exploring the deep sea? First, the deep sea is rich in resources, such as polymetallic nodules and cobalt-rich crusts, important raw materials for manufacturing electronic products and new energy batteries. Second, the deep sea is Earth's climate regulator. Ocean currents in the deep sea regulate global temperatures and absorb large amounts of carbon dioxide, playing a crucial role in mitigating global warming. Additionally, the unique survival methods of deep-sea organisms provide new directions for medical and biological research. For example, antibacterial substances in deep-sea organisms may become sources of new drugs, and studying how deep-sea organisms withstand high pressure and low temperatures can inspire humans to develop technologies for extreme environments. More importantly, the deep sea is one of Earth's last pure lands. Exploring it allows us to better understand Earth's origins and the evolution of life, helping us protect this fragile ecosystem. Although humans have been able to reach the bottom of the Mariana Trench, this does not mean we have conquered the deep sea. Currently, Only a handful of countries can conduct 10,000-meter deep-sea exploration, and each mission is extremely costly and time-limited. Our understanding of the deep sea remains superficial. For example, are there more complex ecosystems in the deep sea? How do seabed geological activities affect global climate? These questions remain unanswered. Furthermore, the extreme environment of the deep sea poses great tests to human physical and mental health. Prolonged exposure to high pressure and darkness can cause various physical discomforts, such as osteoporosis and decreased immunity, while psychological loneliness and depression can impact mental health. This means that even with advanced equipment, humans cannot survive in the deep sea for long. We can only visit this mysterious world briefly as observers. When we look through the submersible's observation window at the darkness and bizarre creatures in the 10,000-meter abyss, we cannot help but have profound philosophical thoughts. Earth is our only home, and the deep sea is like Earth's heart, maintaining the ecological balance of the entire planet. Humans are so insignificant in the universe. Our home planet is just an ordinary planet in the solar system, and the deep sea within the oceans is the most mysterious region on Earth's surface. Looking down at Earth from space, the oceans form a vast blue expanse, and every life in the deep sea silently tells the story of life's tenacity and wonder. We often marvel at the vastness of the universe, yet overlook the countless mysteries hidden right here on Earth. Deep-sea exploration teaches us that human cognition is limited, but our curiosity and spirit of exploration are infinite. Every dive is a challenge to the unknown, and every discovery deepens our awe for life and nature. Perhaps true courage is not conquering nature, but learning to live in harmony with it as we understand it. In the darkness of the deep sea, there lie wonders of life and human awe. We may never fully conquer the deep sea, but the pace of exploration will never stop, for it is this curiosity about the unknown that drives the continuous progress of human civilization. If you have other questions about deep-sea exploration or want to learn more about deep-sea creatures, feel free to leave a comment below. Don't forget to like and follow. Next time, we will explore the mysterious hydrothermal vents in the deep sea and see how life creates thriving ecosystems there without sunlight. Thank you for watching, and we'll see you next time.